Geophysical borehole logging can provide accurate data of the physical properties of geologic units within a borehole environment. This method is a time and money-saving approach that can gather detailed information that otherwise is only attainable by analyzing numerous cores. Logging data is typically used to characterize geology, fracture patterns, fluid flow, and geologic structural properties. Today, we will be looking at tools and data that are typically used for fracture mapping. The basic components of a geophysical borehole logging setup include a winch that is able to carry a signal, a logging control console, multiple downhole tools, and a laptop for data storage, processing, and visualization. Several logging tools are available for use, but as with any project, certain tools can provide better information. We'll be covering a few of the tools used for fracture mapping. The tools to be discussed include 3-arm caliper, single point resistance, optical televiewer, acoustic televiewer, and heat pulse flow meter. Keep in mind that this is only a small sample of the tools that can be used. First up, we have the 3-arm caliper. This is a mechanical tool that measures the diameter of the borehole. When narrow enlargements are seen in the data, this can typically be attributed to fractures in the rock. This tool can be used in dry or fluid-filled holes. On the right is an example of single-point resistance data. This tool measures the electrical resistance between an electrode inside the borehole and a reference electrode on the ground surface. Since water is a good conductor of electricity, sharp reductions in the data can be attributed to water-filled fractures. Next is the optical televiewer. This is a camera that can produce a continuous and oriented 360-degree image of the borehole wall. These are high-resolution images that can be used to determine fracture dip angle, dip direction, and aperture. This tool can be used in dry or clear fluid-filled holes. Another tool is the acoustic televiewer, which can only be used when fluid is present in a hole. However, the fluid doesn't need to be clear to use the tool. This is an ultrasonic device that creates a continuous and oriented 360-degree image of the borehole wall. Much like the optical televiewer, extremely high-resolution images are created, and they can be used to determine fracture dip angle, dip direction, and aperture. In addition, travel time is measured and can be used to develop a 3D caliper log. The heat pulse flow meter, also referred to as HPF, measures the vertical flow up or down in a borehole. Measurements are done while the tool is stationary and can be used under ambient or pumping conditions. Due to its ability to measure low flow rates, HPF is suitable for environmental investigations. Changes in the flow rate are recorded in intervals and then can be displayed as a chart. Now it's time to put it all together. Fractures can be visually picked from the data and shown side by side. Here's a comparison of acoustic televiewer and optical televiewer logs shown alongside the fractures picked from the data. Since depths from the surface are recorded, the data can easily be aligned. The data from the 3-arm caliper, the acoustic televiewer digital caliper, single point resistance, and the HPF data under ambient and pumping conditions can also be shown alongside the televiewer data. This aids in determining more information about fractures, along with which ones are water producing. Fractures and their orientations can then be shown in Rose diagrams to determine trends in the rock. Dip direction and dip angles can be shown in the Rose diagrams as well. With multiple offices throughout the Southeast, Gel Solutions is ready to provide you with geophysical logging services. We also offer a wide range of solutions across our 3 primary service lines, including subsurface utility engineering, geophysical services, and surveying. Contact us today to find out more on how we can help with your next project. Thank you for watching. Gel Solutions. Problem solved.